Optical answer sheets, more commonly referred to as bubble sheets or scantrons, are very popular for multiple-choice test taking. However, the machines traditionally used to grade these tests are clunky, expensive, and they run the risk of damaging the physical answer sheet when processing. We propose a solution that allows bubble sheets to be scanned with a traditional scanner and graded through our software. Ideally, our aim would be for a teacher to use a smartphone to photograph a student's answer sheet and report test statistics back in real time. If we rely on traditional cameras or scanners, our primary concern is with the in-software alignment of the bubble sheet images. We begin by first automatically registering the teacher's image of a test or answer key with an ideal reference template to ensure accurate grading.
The automatic image registration process first corrects for scale and rotation. To do this, we utilize Fourier and log polar coordinate transforms. Beginning with the template and the submission, the first step is to transform both to the frequency domain and then apply a high-pass filter to each one. This removes low-frequency noise, making edges more prominent and ultimately allowing for a better registration. After transforming back into the spatial domain, we now move into log polar coordinates. This transformation allows us to account for and correct scaling and rotational shifts. Using this ratio, R, we calculate the phase difference of the two images. If we take the inverse Fourier transform of this ratio, we notice that nearly all of the values are 0 except for a small area around a single point. The location of this point, the maximum, allows us to calculate the optimal scale and rotation angle. The last step is to correct for translation. To do this, we first need to apply the rotation and scaling we just found to the original submission. By taking the Fourier transforms of this corrected image and the template, we can compute a new ratio R2. Finding the maximum value of R2 allows for the calculation of the necessary translational shifts using these equations. After applying the translation, the submission should be properly aligned with the template.
Before grading a particular Scantron sheet layout, it must be calibrated. This process reveals locations on the scan sheet for us to detect a student's name, ID number, a set of any additional information, and most importantly, the answers themselves. The calibration process requires a user to manually select 4 points on the Scantron sheet: the top of the first bubble, the center of the first bubble, the top of an adjacent bubble, and the top of the lower bubble. This information generates Cartesian image coordinates for subsequent circles on the Scantron sheet. This calibration information is saved and only needs to be done once for a given Scantron sheet layout. A single calibration is sufficient to read answers from an answer key or student submission, saving the appropriate name, ID number, additional information, and test score to a file.
The glue that holds the registration and grading code together is the GUI. This simple user interface is intended to make our Scantron grading method intuitive and easy to use with minimal instruction. The first page of the GUI demonstrates the planned split functionality of our program. Because the calibration method creates a data file stored for future use, our program could, in theory, be used for any type of Scantron. The new template button would proceed down the calibration path and lead the user to the creation of said data file. Following the Grade Papers path takes the user to the template selection page. If there were multiple templates loaded, this page would allow the choice between them. Selecting a template and clicking Next asks for the user to upload a key file for their test. Once the file has been uploaded, a preview of that file appears in the preview pane. The next page deals with the upload of the files containing the papers to be graded. This allows batch selection from any location on the user's computer as the file path is stored upon selection. This also allows one final preview of the file names before grading occurs to make sure the proper tests have been selected. The last page asks the user to select the level of detail returned in the report. Standard reports contain generic grades on a per-student basis. The advanced report would contain full class statistics. The only step left is to input the number of questions on the exam. At any point during the previously described process, the user may go back to a prior page to change any data or settings they wish. Once the user selects grade, however, the grading begins. The program then quickly collects data from each question, identifying the single student's answer as the bubble whose summed code values are the least of all the choices. The completion of the program yields a data file created in the same directory containing the grade data for the class.